Welcome to qnawire.
All right, let's take a look at this function. It's f of x equals 1 plus 1 over x plus 1 over x squared. And we want to find really how to draw this without using a calculator. So that's pretty cool. So I'm going to go ahead and basically rewrite this with a common denominator. So I'll get x squared plus x plus 1 over x. We can see right away whatever makes the bottom go to 0 when you can't factor it is our vertical asymptote. So we have a vertical asymptote at x equals 0. Whoops, that should be squared. X equals 0. And then if I look at high power over high power and reduce it down, if I get a constant, then that is my horizontal asymptote. And so I will have a horizontal asymptote at y equals 1. So let's go ahead and draw these. So we have kind of our asymptotic bounds there. So this is our horizontal asymptote, y equals 1. And we have a vertical asymptote at 0. So I'll just kind of do as close as I can to the y-axis. There we go. Okay, and that is at x equals 0. All right, let's take some derivatives and get a sense of what kind of increasing, decreasing, concave up, concave down, all sorts of different features of our graph. All right, let's also, yeah, okay, so let's do that next. Let's change colors so we can see what we're doing. I'm going to take f prime of x. I'm going to use this first one and take the derivative because this is really 1 plus x to the minus 1 plus x to the minus 2. So I will get a derivative, first derivative 0, and then minus x to the minus 2 by power rule, and then minus 2x to the minus 3. While I'm at it, I'm going to take the next derivative, but I will look at cleaning up kind of the derivative sum and doing a sign chart. But while we're at it, let's just get the next derivative too. Next derivative then is 2x to the minus 3 by chain rule plus 6x to the minus 4. All right, awesome. Okay, so let's kind of clean up what we have here. Let's go back to f prime. F prime of x, I can rewrite as minus 1 over x squared minus 2 over x cubed. If I get a common denominator, then I get minus x plus 2. I factored out the minus 1 all over x cubed. So we're going to look at the critical point. So we need when it's 0 or does not exist. And we can see that we'll get a 0 case critical point when x is minus 2 and a D&E type when x equals 0. So what we should do is keep track on a sign chart of everything we've been learning. Okay, so if this is x and then this is f prime of x, we know at 0 we have a D&E type. Let's go do that a little bit higher. We have a D&E type 0 critical point, and then here at minus 2 we have a 0 type. And we can go ahead and find in each interval whether the derivative is positive or negative. So if I plug in something big like 1, I will definitely get would have been a positive except for this minus out here. So then that becomes a negative. If I plug in say minus 1, I'll get a negative on the top and a negative on the bottom, so that's a positive. And let's see if I plug in minus 3, double negative, but negative on the bottom, so plus. All right, so I think did I do that right? Hold on. If I plug in minus 3, I get double negative, positive, and then negative because of the bottom. So I did that wrong. This is oh no, that was right. It should be a negative. Is that right? Yes. Yes. So I did do it right. Phew. Okay, excellent. Okay, next we're going to look at when the second derivative goes to 0. And I think I'm going to need to make my chart have room for it. So I'll show you why in a sec. So if I rewrite this second derivative as 2 over x cubed plus 6 over x to the fourth, and get a common denominator, then we'll get 2x plus 6 over x to the fourth. This will equal to 0. It also has a D&E type situation when x is 0, but the top goes to 0 if I factor out a 2 on the top here. Let's do that. Let's go back. Oh, there it is. I'm going to make room for this. Okay, if I factor out a 2, I get x plus 3. And we can see that that equals 0 when x equals minus 3. So I really want to make my sign chart bigger so I can include all the features, including this minus 3. So I'm going to go ahead and repeat this, but I'm going to make it to also include the information on the second derivative. I just didn't make it big enough. Okay, so let's go here. We have a 0 feature. We have a minus 2 feature, and we have a minus 3 feature. Okay, so those are for x. For f prime, we'll just repeat. We had a 0 here and a D&E case here. And we had, let's see, we had, when x was big, we had a negative. Minus 1 was a positive. And then if we had something really super negative, you get double negative, triple negative, so minus, and then anything to the left of that. Okay, so let's look at our f double prime. We know we have kind of another D&E weird thing here. We have 0, but here it's at 3. Let's try something big like 2, we'll get a positive. If we try minus 1, we'll still get positive. If we try, say, minus 2.5, I'll get still positive. And if we try, say, minus 4 and plug into f double prime, we get, then we get the negative. Okay, so this is really important because this helps us know so much, pretty much everything. Okay, so let's take a look. Okay, so first of all, we can notice that if I have a minus sign for f prime, that means I'm decreasing. So I'm decreasing concave down. The f double prime tells me I'm concave down. So I'm decreasing concave down. So from that region, I have that kind of shape. Between minus 3 and minus 2, I'm decreasing but concave up. So I've got something like that going on. Between minus 2 and 0, I'm increasing concave up. And between 0 and thereafter, I am decreasing concave up. So something like that. So that will help us with our guided shapes. In terms of mins and maxes, we definitely have a min here because that's where f prime goes from minus to plus. And it looks like we have a vertical asymptote here, so we won't count that as a max because we're not continuous at 0. And here is a point of inflection because f double prime is changing sign, point of inflection. Okay, so we have all this information. Okay, so now let's try to draw it. Let's get some points. We have a min at, well, let's go through and carefully make sure we're now answered all the questions. Okay, first has to do with vertical asymptote. We already did that, but we'll repeat it. X equals 0 and y equals 1 for the horizontal. So we've got that. Okay, B has to do with increasing and decreasing. We can read that right off our chart. Increasing is when f prime of x greater than 0, decreasing f prime of x less than 0. So we can read it right off our chart. We're looking for the positive interval, so minus 2 to 0 for increasing, and decreasing is from minus infinity to minus 2, and it looks like 0 to infinity. Okay, so, and then yeah, that's right, that was decreasing. Okay, good. Then part C was local max, we had none. And local min, we have at x equals minus 2 because f prime of x goes from negative to positive at a critical point. So let's find that value actually. F because that's like a min. It would be nice to know that point. In fact, let's plot a few points, get a sense of what we're doing here. And then the end, we'll have a good picture. Okay, so we know that, let's just plug in 0 because that's good to know. If I plug in 0, then I just get 1. So that's a good point to have. If I plug in, I think that's not correct because I have 0 on the bottom. Never mind. We will not do that point right yet. Okay, we're going to do, let's plug in our min. For our min value, we need the y value at -2. And we're going to plug into our original equation. And so that will give me 1 minus a half plus a quarter. I'm plugging into the original equation. That gives me a half, 3/4. Okay, so we have a min at -2 3/4, so something like this. So that is that's a min. Wow, it's very close to the to our horizontal asymptote. Let's just see what's going on. Let's plug in a -1, just get a little feel for what's happening. Plug in -1, I get 1 minus 1 plus 1 is 1. So we have a point -1, 1. That's right on that horizontal asymptote. And it looks like at this point we are going to keep rising and go towards our, supposed to go through the point, go towards our vertical asymptote. And that makes sense because between -2 and 1, we have this shape. So we're getting that shape and it goes to that asymptote. We know the shape on the far right is decreasing concave down. So I can just, let's just plot a point over there. If I do f of say 1, then I'll get 1 plus 1 plus 1, that's 3. So it's looking like 2, 3, it's looking like we're here. So it's looking like we're going to have this. We'll be bounded by the asymptotes on the right. On the left, we have to figure out how we're going to do this shape and then this shape. We know this is the min right here. We know we have a point of inflection at -3. So let's find out that point. F of -3 is 1 minus a third plus a ninth. So that is, let's see, 2/3 plus 3/3. Wait, 2/3. 2/3 plus 1/9. Okay, so that makes it 6/9 plus 1, so 7/9. Okay, so 7/9 is a point of inflection that occurs at -3. So this was -2. Here's -3. So it's going to keep being okay, so this is the min. Okay, so here's the point of inflection. This is so interesting. It's super tight in here, but it has to have this shape be to the left of -3. So kind of that shape. And then this shape to the right of -3, just to the right. So we get something like this. Wow. Huh, I think we did it. I think that's all the parts. Let me just double check we didn't do anything missing. Oh, last thing is we had to specify our concave up, concave down. So let's do that over here on the left. So D concave up is when f double prime of x is greater than 0. We can look on our chart. That's -3 to 0 and also 0 to infinity. And then concave down is when f double prime of x is less than 0. And so that is -infinity -3. Whew, okay, did we do everything? Point of inflection, we already knew came at -2, sorry, at -3 was point of inflection. Right here is our point of inflection. That was at -3 7/9. Ooh, okay, did we get everything? I think we got everything. Wow. All this work to graph without a graphing calculator. Aren't you happy we have graphing calculators? But anyway, this is how they used to have to do it before, and we can still do it now. Alrighty, take care. Have a wonderful day.